All right, so it's time to move on to section 5.3, which is about independence and the multiplication rule. All right, so two events E and F are independent if the occurrence of event E in a probability experiment does not affect the probability of event F. Two events are dependent, i.e. not independent, if the occurrence of event E in a probability experiment affects the probability of event F. All right, I think this will become clearer as, I gotta move my thingy over here, as we work through an example. So determine whether the following events are independent or not. A coin lands on heads, then rolling a 5 on a single-sided die. All right, so when you flip the coin, it doesn't really have any effect on what you get on the die, right? The two items are independent of each other. Cool? All right, now what about a gumball machine? So you leave a restaurant, you get a red gumball from the machine, then getting another red gumball from the machine, right? So getting a red gumball in the first place affects what's left in the machine, right? That means that by definition it has to be dependent. Okay? When getting that first red gumball out affects how many blues there are left, how many reds there are left, how many whatevers. It affects the overall proportions. All right, your first child is a girl, then your second child is a girl. Well, in general, for most healthy couples, that's independent. The gender of your first child does not have any bearing on the gender of your second child. There are, of course, some exceptions to that due to genetic anomalies and such, but for most people, that's independent. And so we will treat it as if it's independent for the population. All right, being dealt an ace, then you're dealt a king. Well, that's definitely dependent, right? Because cards, by definition, when you're dealt a card, you're affecting what's left in the deck. So it can't be independent. All right. You dealt an ace, but then you replace the card, and then you're dealt a king. Well, that's independent. That's the point of the replacement of the card. It's the kind of thing that a magician tries to do, right? All right, done with that. Oops. There we are. Okay, I've got to go back and find our data. Hold on one second. There we go. I've got some data here. All right. So, looking at our Harry Potter movie data, are the variables gender and number of Harry Potter movies independent? Explain. Well, just in general, the answer has got to be no, right? Okay, so now the question is why. Now, there's a couple ways you could figure this out. And one of them is going to involve a rule that we will get to down here, but we won't mention it at this point. At this point, let's just think about this. It appears that knowing that you, for example, have seen 8 movies, you're far more likely to have been a woman than to be a man, right? So, in general, gender and number of Harry Potter movies seen are not independent because, for example, knowing your gender affects the probability that you've seen all 8, right? So, for example, knowing that I'm female means I'm much more likely to have seen all 8 than knowing that I'm male, for example. All right, we're going to get a little bit more fine-tuned with that one in a minute, but just bear with me for right now. Okay, now, one other comment I wanted to make before we head into the formal rule down here. Disjoint. Okay, so disjoint is something that we talked about in section 5.2. Disjoint means you have no outcomes in common, no overlap, right? So, for example, when you flip a coin one time, you either get heads or you get tails, but you can't get both. That's disjoint. Independent is really talking about more than one event happening in concurrence. So instead of flipping a coin once, you flip a coin twice or more. Then tossing a heads on the first coin flip does not affect the probability of a second flip. Okay? And it's kind of a weird thing to think about, but disjoint events can actually never be independent for a variety of reasons, but mostly because once you know that you've got heads, for example, then there's no way it could be tails. You're affecting the probability. You're making it 0. It's a kind of a weird sidelight, but that's just the way it is. So disjoint can never be independent, period. All right, we'll be back for the formula next time.